Okay, y'all, welcome to Unit 4 of 7 for the year. Unit 4 is all about functions, and I've heard it is fun. And you've done some stuff with functions last year. This is going to set up to move into specific types of functions moving forward. And we will have a mid-unit quiz and a unit quiz. It's about 18 lessons long. I was hoping to squeak in the first one before break, but it's going to likely be a couple days after we get back from break, all right? Sure to get into this. We're going to always focus on big ideas and concepts. There's not going to be too much mathy today. We're going to look at getting some language in place. So we're going to jump in. We got to warm up and check this out. We got bagels. Yeah, hey, so one important thing, just to keep things rolling, is if I'm like, hey, here's our situation, we have bagels, yelling out things about bagels would be inappropriate for students, so we're just going to stay on track, okay? We have some bagel prices here. A customer's at the shop getting a baker's dozen. I don't know if you ever heard of baker's dozen. So it's 13, and the shopkeeper says, hey, that'll be $16.25. And Jada, Priya, and Han, they all think the baker is wrong. They think. Jada's like, shouldn't it be $13.25? No disrespect, sir. Priya says, I think it should be $13. No disrespect, sir. Disrespect. And Han says, no, I think it should be $11.25. No disrespect, sir. Here's what's up. They're all right. It's your job to figure out why they're all right, including the shopkeeper. Who can talk us through how the shopkeeper is correct? What did the shopkeeper do, Spencer?
It's probably
Okay, Asher?
They did the one bagel payment times 13.
Yeah. They said each bagel, $1.25. You owe me $16.25. Why is Jada right? Albert?
So what Jada did was she looked at the 12 bagels and then
Okay.
she did the 6 bagels divided by 3. So she got $2 for 2 bagels and then she took the 1 bagel.
Oh, 6. Oh, that's different than I got it. That's cool. So you're saying she did a 12, half of a 6 and a 1?
A third of a 6.
A third of a 6 and a 1. Okay. Did anybody get it a different way by raising your hand? Elliot.
I got it. I think we went 9 bagels and then 4 bagels for 1.25.
Yeah, that's cool. Oliver, you did it a different way than I've seen. That's cool.
That's not bagels though. No, it'd be 2, 6.
Oh, that's only 12 bagels.
No, I said 9 plus 4, $1.
Oh, yeah. So 9 bagels is $8. So 9 and 4 is 30. Yeah, we have 13.25. This is not 8 bagels. This is $8. Okay. How did Priya get $13, Hadley?
No, I know that's $8, but like
That doesn't add up to 25.
No, that would be.
It doesn't add up.
Oh, yeah, this would just be 13, not the 13.25.
It would be.
that works for Priya.
That works for Priya? Okay. We do need 13, so you're saying Priya is 9 bagels at $8 plus $1.25 times 4 to get $13? Okay, so how did we get Jada? Other than, we got Oliver's way. What's another way, Micah?
I think that we could get Jada by doing 6 bagels and then 6 individual bagels.
6 bagels and 6 times 125. That's not gonna work. That's a good try. Right, we got Will.
2 6s and a 1.
2 6s and a 1, so $6, $6 and $1.25. That's how I've been seeing it. But again, I'm stoked on Oliver's way. I haven't seen that one before. A half of a 6. Okay. Yeah, maybe not, but still, it's cool to think about. Han. Willa.
It's just the price of 12 bagels is just $10 plus the price of 1 bagel.
Yeah. A 12 and a 1. Now, here's why there's probably different prices for different bagels. I'm guessing just by experiences I've had. If the bagels are all mixed up, and they have to go grab 13 different bagels, it takes more labor at a place. Versus having a package of 12 bagels where they just grab a whole package of one type of 12 bagels. So we maybe need more information. Are they all, to get the deal, do they all have to be the same type of bagel? So it's sort of like, my context, surprise, surprise, is bacon. Okay? At Fresh Town, bacon's on sale in the meat thing in the counter. It's $1 more per pound on sale still to have the guy go in there, reach in and package it up and weigh it and stuff. Other than they have it like vacuum sealed off to the side. When it's vacuum sealed off to the side, it's 1 pound. No, it's the same thing. They just pre-vacuum sealed it and it's all stacked up somewhere so you can just grab it. Or if you're not into bacon, at Fresh Time at least, apple totes are usually a little cheaper per pound for apples than the ones that are like stacked up. Because if they're in bags, people can just grab a bag and you're not using like labor to like stack them all up. It's just big bags ready to grab. Okay. So maybe that's like the same kind of thing. So like maybe if you're getting this $10 12 bagels, they have to all be the same type. And it's in a bag already. But these kids rolling up here, maybe they're all getting 13 different single bagels. I don't know. We don't know. I say, get some variety. Not everybody likes the same bagel. Emmett. Today, we're re-getting into functions. And a lot of times people think of a function as a machine where something goes in and then something comes out. We've already done a bunch of functions. We did linear functions, right? So when we had a line, we input what variable into the line usually? X, and the outputs? Y. Right? So you can think of it as the function is the rule. X goes in, Y comes out. X you're also going to hear called the input or independent variable, and the Y is the dependent variable. I like to, and then the other thing that you're going to take note, and I'm going to reference this often, is the definition of a function. Exactly one output for each input. Okay? So this gets tricky. If each input has exactly one output, can multiple inputs have the same output?
Yeah.
Yes. And I like to think of it kind of like the analogy is this. A vending machine, yep. And my favorite beverage in the vending machine is Coke Zero. And I'm getting a Coke Zero out of there. Does it matter what combination I push? No. All combinations will give me a Coke Zero if it's a Coke Zero only machine. But if I put combination, let's say C4, is it coming from a random spot?
No, it's
coming from the C4 spot. Now, if I hit spot D2, I get the same Coke Zero. Or I get a Coke Zero. But is it from the same spot? No, it's from its spot. Okay? So that's how I kind of remember what can and can't be a function. Now, if I hit in D2, if I hit D2 and it's just coming from random spots, not D2 spot, is that a function? No. Okay. Cool. So you can think about that whatever you want. I know kids aren't always that into Coke Zero, maybe Snickers or something. Okay. In a moment, I will assign you one of these 3 days for the dog. This dog is tied up by a 5-foot leash outside a store as the owner goes in to get a beverage. You can't take dogs into stores usually, okay? On day 1, they walked around the entire time while waiting for the owner. Day 2, walked around for the first minute, then laid down. And day 3, tried to follow the owner into the store but stopped. Then started walking around the post in one direction until its leash was completely wound up, okay? Then it stayed there until the owner returned. Each day, this is important, each day the dog was 1.5 feet away from the post when the owner left. And each day at 60 seconds after the owner left, the dog was 4 feet from the post. I am going to give different groups different days to sketch a graph of their situation. It might not match perfect. So let's talk about day 1. Let's talk about day 1. First of all 3 of them have non-negotiables, right? They started at 1.5 feet. And at 60 seconds, they were all at 4 feet. So we all have those same points of reference, right? On number 1, the owner left. And what'd the dog do? Just walked around. So it doesn't have to... It could be like random. Now, a lot of stuff I saw was kind of jagged. It's probably more loopy and curvy. Like dogs probably aren't really good at walking at a perfect constant rate. Okay? For day 2, the dog went to the end of the leash, came back a little bit, laid down. So it could be true. Like I see a lot of people that draw a straight line like from this dot to this dot, but that means the dog walked at a perfect rate for 60 seconds until it was done. If you ever watch a dog, they're unlikely to walk on a leash at like a perfect.
It's possible.
I didn't say it's impossible. I would say it's unlikely. And we're trying to. And day 3, this dog followed its owner, zoop, hit the end of the chain. Then it started winding itself around. Why does it wind up faster eventually?
Because it's since he's doing circles around the pole, basically the circumference of the circle gets less.
Yeah.
The leash gets more.
So this shape's and then eventually, it's not gonna hurt itself. It's gonna stop once it gets too close to the pole. We're not gonna go to 0. Can't really go to 0 because then it'd be like getting choked or something. Okay. Cool. So we're gonna talk. You should already know these things. The independent variable is the input. So in context of this dog walking around the pole and stuff, what's going to be our independent variable? Time in seconds, right? Time changes what? Distance, which is why the distance is the dependent variable. So it's great to reference like this time change distance. And notice that any of these. Was there any one time where at one time there's 2 different distances? No, because the dog can't be 2 different distances at the same time. The dog can only be, they could be at the same distance more than one time. Look at this. They were 3 feet away 1, 2, 3, 4, 5 times. Right? You see, so that could be true, but that's the dependent variable.
But there's only one dog.
Yeah. Okay. So what you're going to work on now, I'm going to show the dog bark. You're only going to work in time in seconds since the owner left and total distance. So what's different about this? Time in seconds since the owner left and total distance. What's different about this situation?
Instead of distance from a pole.
Instead of distance from pole, it is total distance. You're going to answer questions 1, 2, 3 and sketch a possible graph. Most people's graphs are going to be different. So the first one I want to show you, this one is the one I said I would do. This is the barks over time.
Scatter pole?
No. You're not listening. You did how far they walked. I did barks. Okay? So I would say something like barks are a function of time. The amount of time that passes changes the number of barks that had happened. Now, one thing you're going to notice, I did hear someone reference mine it's kind of a scatter plot. Why don't I have this going on?
Because like that would suggest that in between those dots he made like a partial bark, but
Yeah.
you can't partial bark.
You can't have partial barks, man. There's not fractions and decimals of barks. You either bark or you didn't. Okay? Bob, I'll argue with you about it later. So, this is what we call a discrete situation. And this is independent, and this is dependent. And I always like to rephrase when I'm done. The number of barks depends on how much time has passed. Okay?
Wait, so is the x-axis always independent?
Yes.
Yeah.
But you could always ask, could it be a function of it? But like in practically speaking, it'd be a pretty messed up dog if the number of barks changed the time.
Time travel.
Yeah, time
travel.
Awesome dog.
Maybe I missed that part in Bolt. Okay? And here is an example of the distance. So, one thing, make sure you did not go down ever. Okay? Make sure your graph didn't go down ever. So, it could go down previously when we were distance from the pole. But if this dog's walking around, what should only happen to the distance? It goes up. It has to go up. Okay? And then why isn't this one just dots?
Because you can like partially move.
Yeah, this ain't no teleporting dog.
It would have to be jumping around.
Not even jumping around, because when you jump, you still travel that distance.
Only teleport, you still travel that distance.
Teleporting dog, no, you're just here and then you're here. So
That's not walking though, it's jumping.
this is called continuous, and it shows everything in between. It could. So I saw some of this out there, but it's unlikely that the.
I'm saying like,
Well, this means they didn't walk at all.
yeah.
I don't think so.
Can it be negative if not time travels again?
Yeah, no time traveling dogs. So, again, I saw some of this. I would expect a dog not to walk like in a perfectly
Yeah.
straight, consistent, right? One thing that could happen, it could chill for a minute. Like there could be some flat spots. I guess I couldn't. You can't go completely vertical like that because that would be instant speed up. But a lot of people's could look different. Again, time is independent. The distance is dependent, and the distance is a function of time.
Wait, couldn't you go like very, very, very close to the vertical?
Oh, close to vertical, but if you can't go exactly vertical, because then guess what? Is this a function?
No.
Look at all those outputs for the same
No,
input.
dog just goes 0 to 100.
Okay, it's a Tesla dog.
0 to 100 is
All right, we're gonna do a lesson summary now. I can pause the video for these directions.